So today I'll show you how to evaluate an integral of a function which is known as Gaussian function. So let us do it. So this is the function which is exponential of minus x squared. This is known as Gaussian function. And if you plot this function, it would look something like this, bell-shaped curve. All of us know about it. It's a symmetric function or an even function around x equal to 0. And if you integrate this function from 0 to infinity, you get root over pi by 2. But if you make the integration from, say, minus to plus infinity, and you can guess what is the answer. Answer is nothing but root over pi, because it is symmetric. It's twice what you get when you integrate from 0 to infinity. Okay. Now, this is a standard integral. You use it everywhere in quantum mechanics, in statistical mechanics. But how to evaluate this integral? Let us do it. So we know the answer. So the answer is, we know the answer is root over pi by 2. This is the answer if you integrate from 0 to infinity. But how it is? Root over pi by 2. So let us do it. So let us define this integral as I. Since x is like a dummy variable, I can always define this integral as in terms of some other dummy variable like y. So this is also I. So if I write down I square, so you have this integration. So 0 to infinity exponential minus x square dx times 0 to infinity exponential minus y square dy. Okay. And I can rearrange a bit and write it as 0 to infinity dx, 0 to infinity dy, exponential of minus x square plus y square. This is I square. So if I can evaluate this integral, if I take a square root of this, I'll get my integral I. So let us do it as follows. So I take a point in xy plane and I join this point to the origin, and the distance is r. So then the projection of this point on x and y axis would be as follows. X is going to be r cosine of theta. Theta is the angle this vector makes with the x axis. Okay, so similarly y is r sine theta. And it is obvious that if I do x square plus y square, it is nothing but r square cos square theta plus r square sine square theta, which is again nothing but r square times 1, which is r square. Why 1? Because cos square theta plus sine square theta is 1. You know this. This identity everybody knows. Okay. So this integral is now going to be an integral of exponential minus r square. But now the integration is not going to be over x and y, but it is going to be over r and theta. So actually you make a transformation. You go from xy coordinate system to another coordinate system, which is called r theta. And when you make such transformation, actually you need something known as Jacobian. So Jacobian is as follows. So this is your dx dy coordinate system, which is connected to dr d theta, this variable d theta, with this Jacobian j. J is called Jacobian. So it is, so this integration is now going to be like this. You have this Jacobian dr d theta, and we'll put the limit later. I'll see what is the limit. This is I square. Okay, so you have to evaluate this integral. So let us do it now. So this is my integral. This is my integral I. square, which is, exponential minus r square. You have this dr d theta, and I have this thing, and also you have j sitting inside. Now, what is this Jacobian? Now, this Jacobian is given by this determinant, which is dou r, sorry, so let me write down here. So x is cos theta, and y is sin theta. And this Jacobian is going to be del x or dou x, dou r, dou x, dou theta, divided by differentiate y with respect to r, and then again with respect to theta. And I can do this differentiation very easily. This one is nothing but cos theta. This one is nothing but minus r sin theta. This is again r cos theta, this sin theta. And this is nothing but r cos theta. So if you compute this Jacobian, it is going to be r cos square theta plus r sin square. This minus sign is there, so it's a plus. So essentially, this is nothing but r. So the integral is now nothing but I square. So let me write it like this: r exponential square. So what are the limits? Limits of r is from 0 to infinity. What is the limit for theta? Remember, we had this picture in mind. This is x, this is y, and this is r, this is theta. This is the point. So r can be anywhere from 0 to infinity, always positive, but it should be only on the first quadrant, which essentially means the theta can vary from 0 to pi by 2. So it is from 0 to pi by 2. 0 means on the x-axis, along the x-axis, pi by 2 means along the y-axis. So so essentially, this is the integral you need to do. You can do this theta integration very easily. It is pi by 2, and then you're left with this r integration. And this is also very easy to do. How do you evaluate this? So I can assume that, okay, z is something like r square, then dz is twice r dr. So r dr is nothing but half of dz. So this integration now has become pi by 2 times half of dz exponential of minus z. And integration limit is again 0 to infinity. So this is nothing but pi by 4 times this integral. And everybody can evaluate this integral, the exponential function. This is nothing but pi by 4 times exponential of minus z. Put the limit 0 and infinity. This is nothing but pi by 4 times exponential of minus infinity minus exponential of 0. Okay. Yes, but I have a minus sign here because we have this minus. So essentially it is pi by 4. Because exponential of minus infinity is 0. 0 minus 1. This minus of this minus will take care pi by 4. So your I square is pi by 4. Then your I is nothing but root over pi by 2. And what is this I? If you remember, this is this integral. So we have now proved that integration of this Gaussian function from 0 to infinity is root over pi by 2. And if you integrate from minus to plus infinity, it is going to be twice of that, which is root over pi. Thank you very much for watching.